Hello everybody, welcome back to your Unit 4 review lesson. So today's lesson is for Wednesday, April 22nd. We're going to be going over atmosphere and then also take a look at watersheds today. A quick announcement before we get started. So College Board has sent out emails to you guys. Apparently they did it over spring break. So please check your email with whatever email you signed up for College Board. So when you log into College Board, whatever email that you use to do that, make sure you log into your email and go find the email from College Board that they sent out. I think they said it was last week, confirming which AP test you're signed up for. So they basically just want to get a head count and make sure that you're signed up for your AP test and that you're signed up for the correct AP test. So make sure you're looking out for that. If you don't see it, they said to check your spam folder because it might have gone into like your junk mail. But it's really important that you guys get signed up for that AP test. And if you have any questions about it, I do have an email saying how you can access it. So I can send that out or tell you the steps of what you need to do if you can't find it in your email. And then they're supposed to be getting out a way that we can check to make sure you guys are signed up a little bit later this week. So I'll keep you guys updated on that. For now, let's move into a review of our essential knowledge for Unit 4. We're continuing with our earth science concepts. So let's review really quickly Earth's atmosphere. So remember, our atmosphere is made up of major gases, each with its own relative abundance. So we're going to see that on the next slide. So your atmosphere has really just a few major gases that it's made up of. A lot of times when we think about it, we think, oh, oxygen is abundant in the atmosphere because we as living organisms breathe oxygen, but really the major composition of the atmosphere is going to be nitrogen. And then the layers of the atmosphere are based on temperature gradients and include the troposphere, which is at the bottom, the stratosphere, the mesosphere, the thermosphere, and the exosphere. And remember, our exosphere is just basically like outer space. So here is our temperature gradients and our composition breakdown of our abundance of our different elements in the atmosphere. So while oxygen does make up 21% of the gases in our atmosphere, nitrogen is actually the largest makeup. So remember, if we go back to our nitrogen cycle, nitrogen can't be used as a gas. It has to be fixed by those bacteria in the soil and turned into ammonium and so forth. So our largest abundance in our atmosphere is going to be nitrogen. It exists as N2. It's a gas, then oxygen. And then also we've got argon and also carbon dioxide. Now, carbon dioxide is one of the major greenhouse gases that does lead to global warming. Its composition in the atmosphere, it's not, a major gas, but there's enough of it that we're pumping into the atmosphere to lead to that greenhouse effect and thus global warming. So if we take a look at our temperature gradients and then the way that our atmosphere is broken up, we've got our troposphere on the bottom. Remember, this is where we live. This is where our weather occurs. And as you increase in altitude, your temperature decreases, right? Because the air is thinner, right? There's less density of the molecules, and so it gets a little bit cooler. Now, when you get to the stratosphere, now you're still increasing in altitude, so the density of the molecules are going to still be decreasing, but we see an increase in temperature here. And that's because that's where our ozone layer is. Remember, ozone is O3. It forms in the presence of sunlight. And because that ozone layer exists here, it traps radiation and holds onto it. So we see an actual increase in temperature as we move to the stratosphere. Mesosphere, we don't have an ozone layer or anything there, so we do see a decrease in temperature. Then when we get to our thermosphere, we see another uptick. Okay, so we see an uptick in our temperature, and why would that be? Is because this is where most of the solar radiation is hitting the atmosphere. Okay, so when you think about solar radiation hitting the atmosphere and warming it up, that's why we see that temperature increase. Now, we have our ozone layer to help protect us. A lot of radiation does make it to the troposphere and it heats up our surface. We know that, but this is where the majority of that radiation is hitting, especially like X-rays and ultraviolet rays up here, which is causing that uptick in the temperature. Talking about global wind patterns. So remember, global wind patterns primarily result from the most intense solar radiation arriving at the equator, resulting in density differences and the Coriolis effect. So remember that the part of the Earth that receives the most solar radiation is going to be your equator, right? So They don't really see a difference in seasons. The radiation is pretty intense there all year round. And then that density difference, because of the radiation, is going to be what really moves our global wind patterns. So a reminder about our Coriolis effect. So that's something that you guys have to know. So basically the Coriolis effect is caused by the rotation of the Earth. And basically what that says is that in the northern hemisphere, objects will be deflected to the right. And then in our southern hemisphere, objects are deflected to the left. Okay, so we live in the northern hemisphere. So objects would be deflected to the right up top and then to the left on the bottom, so in the southern hemisphere. And then these are just kind of a depiction of your global wind patterns. So we've got our easterlies, our westerlies, our trade winds, and our southeastern trade winds. And then you have your polar cells, your mid-latitude cells, and then your Hadley cells. So remember, we talked about this too in relation to like El Nino, which we'll get to on Friday. But what happens is like kind of the same concept with the convection currents in the magma in the Earth's crust, except this time we're talking about air. So all this radiation, right, hits the equator. This air warms up, it becomes less dense, it rises, right? It cools as it travels, and then once it cools, it becomes more dense, falls down, warms up, and it goes in this cycle, right? And this is kind of what pushes our global winds, but also our weather patterns as well. The last thing we're going to go over today is going to be watersheds. Now, we glossed over this very briefly. So we were doing Unit 4 back in November before your Thanksgiving break, and you guys read an article on watersheds when I was gone for my wedding. So what we're going to do today, you guys are going to complete a web quest so that you can kind of dive a little bit deeper into watersheds, just in case there's a question that comes up on your AP exam. Basically what a watershed is, it's just an area that basically collects all the precipitation, so rain, snow, that falls, and then it's all like the interconnecting tributaries and rivers that kind of filter into a larger body of water. Okay, so, and then based on where you are in the United States, you'll be in a different watershed. So it's defined basically by which streams, which rivers are flowing into the larger body of water. Today in your web quest, you guys will be looking at the Susquehanna watershed. I think that I said that right. It's a really large one. So you guys are going to explore kind of what's going on there, where it's emptying, what are some of the environmental issues that's going on in that watershed. So basically, characteristics of a given watershed include its area, length, slope, soil, vegetation types, and divides with adjoining watersheds. So watersheds are kind of interconnected across the country and across the world, but you do live in a very specific watershed based on where you are. And like the mountains, if there's a mountain region, that can affect, you know, how quickly water empties into a stream or a lake, what have you. So it just depends. It depends on the geography of the land. Obviously, we in North Carolina, we do have, you know, coast, Piedmont, and mountains. So it's a little bit different. So just to review, we can go ahead and do this really quickly. Solar radiation also affects Earth's seasons. So the incoming solar radiation, which is called insolation, is the Earth's main source of energy, right? The angle of the sun's rays determines the intensity of the solar radiation. So we know that the equator gets the most solar radiation. And then due to the shape of the Earth, the latitude that is directly horizontal to the solar radiation receives the most intensity, aka the equator, okay? And then the highest solar radiation per unit area is received at the equator and decreases towards the poles. So we know that our poles are cooler because they don't receive as much radiation, which warms the Earth. Okay, and so as, you know, we rotate through space around our sun, the solar radiation that's received at a location on the Earth's surface varies seasonally, right? So when we are in our summer months, we are receiving more solar radiation. When we're in our winter months, we're receiving less, okay? So the most radiation is received during the location's longest summer day, which is summer solstice. A lot of times it's in June, and then the least on the shortest winter day, which is typically in December. So we've got a summer solstice and a winter solstice. The tilt of Earth's axis of rotation causes the Earth's seasons, and then the number of hours of daylight in a particular location on the Earth's surface. Now, we do have daylight savings time, which can basically daylight savings time was for farmers. So in the summer, you would have more daylight to work in the fields. And now, you know, there has been some debate as to whether we should do away with daylight savings time, because it's kind of just like a natural progression of the seasons to have variation in the length of the days, but I digress. So the cause of the seasons, so Earth's seasons are caused by the tilt of the Earth's axis and the amount of radiation, okay? So the tilt of the axis and the amount of radiation that's being received in a particular area, okay? And remember, the seasons are flipped in the hemisphere. So when we have summer, the southern hemisphere is having winter and vice versa. And that's going to be it. So what I need you guys to do now is go back into your assignment for today and find that Watershed web quest. You guys are going to complete that. You can do this one of two ways. You can make a copy of it and type your answers directly into the document and then just upload it. Or if you just wanted to open a separate Google Doc and literally just like number it, I think it's 4 through 24 you guys are doing, and put your answers on that and then share it with me directly to my email, that's totally fine. I hope it doesn't take you a long time, but you guys do have a couple days to finish that. And then on Friday, I will post up your FRQ for the week, and we will just keep rolling with this studying. Again, make sure you guys are checking your emails. If you cannot find your College Board email, make sure you're using, again, the email that you signed up with College Board with. If you can't find it, check your spam mail. And if you still can't find it, let me know, because we got to make sure you guys are signed up for that test. All right, I hope you guys all have a wonderful day. I will talk to you Friday, and I will set up a Zoom meeting probably for Friday as well, so that we can all meet and just kind of check in and see how things are going. All right, you guys have an awesome day. I'll talk to you later.